Hello guys, we are back with our next lecture. In this lecture, let us go through the next topic, okay? That is a cache replacement policies, guys. Okay, so till now we discussed about different mappings and all those things, right? So we discussed about direct mapping, associative and set associative. Okay, so whenever all the slots, that is nothing but all cache lines are full, so how to replace them? So that concept we will learn today, guys. Okay, yes. So as we know, when a cache is full, we need to replace some to give space for the new blocks, right? Yes. So when the space is full, you need to reallocate someone, right? So you need to send someone out and you need to place our new required one, right? Yes. Hence, to decide whom to remove or replace, we use a cache replacement policies. Okay. So in direct mapping cache, okay, the position of each block is predetermined. Hence, no replacement policy is needed. Okay, so let us recall few things, guys. So if you recall, in direct mapping, okay, so if there is a cache line 0 and if is there cache line 1 and if there are block 1 to block 7, so we used to allocate them like this, right? So each and every one is a pre-decided where to go, right? B4, B5, B6 and B7. Okay, so in any case, whenever the slots are full, so assume B0 is occupying and B1 is occupying. So if B2 comes, is there any rule to check who to go out, guys? So obviously B2 has only one thing. It will ask C0 whether there is space or not. So if it says no space, please, it will remove it and it will give place for this. So in that way, there is no need of any page replacement algorithm right here. So there is nothing to check, directly remove it, that's it. Right? Yes. So that is the reason why in direct mapping there is no concept of page replacement. Okay. Whereas in fully associative and set associative, okay, in fully associative there is full freedom, right? So if a B node comes, it will come here. If a B2 comes, it will come here. If a B7 comes, whoever is failing the case, that is nothing but whoever does not have good replacement, so basically it will be replaced. So basically whichever fails in our given method, so that will be pushed out, that is nothing but it will be removed and B7 will take its slot. So in that way it will work. So in both fully associative and set associative, the same concept. Okay, yes. So there are three methods, guys. So the first one is FIFO, that is a FIFO, guys, first in first out. Okay, the second one is least recently used, LRU. Third one is optimal. Okay, guys, these concept we will again repeat in OS, guys. Okay, so now you will be getting a clear idea, and in OS you will be getting more and more clear idea about this topic, guys. Okay, yes. Okay, so mostly the examples and everything will be the same, guys. I'll be just copying the same concept again. Okay, yes. Okay, so in this lecture, let us discuss about FIFO, guys. It's just 3 minutes, right? Yes. So let us discuss about FIFO now. Okay, so what exactly is a FIFO? First in, first out. So whoever comes inside first, he will only go out first. Okay, so this sometimes appears like a queue, right? So whoever is coming inside first, he will leave first. Got it? Yes. So that is the concept of a FIFO, guys. Okay, so now most of the students will be like, we understood something, but we don't know what we understood, right? Yes. So now let us take a small example so that you can understand it 100% clearly, guys. Okay. So let me write down the example so that we can try to solve it. Guys, please take a piece of paper, everyone. 7, 0, 1, 2, 0, 3, 0, 4, 2, 3, 0, 3, 2, 1, 2, 0, 1, 7, and 0 and 1. Okay, yes. So and in question, so this is the series which we want to push, guys, assume in that way. So we are having a cache of 4 slots. So indirectly 4 lines are there. So and these are the block numbers, assume in that way, and you want to store them here. Okay, okay, okay. So let us start. Okay, so initially we are having the 7, right? Yes. So our cache is completely empty. So let me draw a line here. So let me draw 4 boxes, guys, because it will be easy for us, right? Yes. Okay. Yes. So initially our cache is completely empty. So what we can do? We can directly give the first place to 7. Okay. So now 0 came. Okay. So there is below slot, right? So let us write 7, 0. 1 came. 7, 0, 1. Then 2 came. 7, 0, 1, 2. Okay. So now 0 came. but 0 is already in our list, right? So indirectly there is no need to do nothing here, right? Yes. So you can give some kind of snake or some kind of pattern you can draw there. Okay. So there's no need to repeat it. Okay. Yes. Okay. So now continuing 3 came. Okay. So if you observe carefully, all our 4 slots are full. So what we should do now? So who came first, guys? 7 is the guy who came first. So let us push him out. So now 3, 0, 1, 2. So again 0 is already here. So let us do nothing. Okay. So now 4. So who came after 7, guys? So first we removed 7, right? So 7 is gone. So who came after 7? 0. So let us remove 0 now. 3, 4, 1, 2. Okay. So now 2 came. So 2 is already in the list. So 0 is also removed. 2 is already in the list. So let us just strike it off. So now 3. Okay. So wow, 3 is also in the list. That's really good. Moving on, 0. So 0 is not in the list. So after this 0, who came, guys? So 1 came. So let us push 1 out. Okay. So then what it will be? It will become, okay, 3, 4, 0, 2, right? Yes. After that 3 came. So 3 already has its slots. 2 also has its slot. Nice. 1 doesn't have a slot. So 2 had, okay. So what did we push last time, guys? Outside. So we pushed 1 outside, right? Yes. So now 1 came again. Okay. So what we will push out? 2 we will push out. That is nothing but a 3, 4, 0, 1. Okay. Again 2 came. Now we need to push 3 outside. Okay. So we need to push this 3 outside. That will become 2, 4, 0, 1. So 0 is already having its slot. 1. So 3 has been pushed out. So next item is 4. So 2. Okay, sorry, 1 already has its slots, right? So there is nothing to do. So now coming on to 7. So 7 place will be occupied by 4, right? Yes. So 2, 7, 0, 1, right? Yes. So now coming on to the below. So 0 is already having a slot. 1 is also having a slot. So at the end, we got this as a result, guys. Okay. Yes. So now you understood, right? So whoever comes first, you will slowly push them out blindly in order. Okay. Yes. So now you are getting an idea, right? Yes. Okay. So whenever you entered a new element inside, so that is called as a miss, guys. Because 7 is not found in the list, right? So that is the reason why this is called as a miss. Similarly, 0 is also not found, so it is miss. 1 is also not found, miss. 2 is also not found, miss. But 0 is found, hence it is a hit. Similarly, miss, hit, miss, hit, hit, miss, hit, hit, miss, miss, hit, hit, miss, hit, hit. So let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many misses are there, guys, in total? So there are total 10 misses for our given string when we used 4 cache lines. Similarly, how many hits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So exactly 10 hits and 10 misses are there for our given question. Got it? Yes. So this concept is nothing but first in, first out, guys. Whoever comes inside first, push them only first out whenever you want an empty slot. Got it? Yes. Okay, so now let us go through the same book explanation which I have written. Okay, so the block which has entered first in the memory will be replaced first. Okay, so we gave a block sequence and we told that how many lines are there? 4 lines. Okay, yes. So the same question I have just solved in my paper. Okay, yes. So now you got an idea, right? Yes. And one more important concept with respect to first in, first out is the concept is Bailey's okay, sorry. I think it is Bailey's, right? Okay, just give me a second, guys. Okay, sorry, it is Beladay's, right? Yes. So it is a Beladay's anomaly. Beladys. Okay. If I am pronouncing it wrong, I am sorry for that, guys. Okay. Yes. So that is a Beladay anomaly. So basically, what did the scientist say is, so what is the ideal case, guys? So let us take a small thing here. So here, how many cache lines are there, guys? So 4 cache lines. Okay. So if I say a small thing like, I will increase my cache lines to 7. What will happen to my miss ratio, guys? So what will happen to my number of misses? So most of the students will be saying that they will decrease. Okay, but that is not always, guys. So that is what Bailey wanted to say. Okay, Bilede want to say, sorry for that, Bilede want to say. So we assume if a number of cache lines increases, faults will decrease. But in FIFO, we might have same case in which faults increases if we increase the cache line. So that he gave that name as Bilede's anomaly. Got it? Yes. So now let us take a small example, guys. Do you want me to solve or shall I show it in the book, guys? I think everyone will be saying, please solve, right? Yes. Okay. So anyway, I'm always ready to solve it. So let us start. So we are initially, let us assume we give 3 cache lines. Okay. So the input is 1, 2, 3, 4, 1, 2, 5, 1, 2, 3, 4, 5. Okay. So how many cache lines I told, guys? 3 cache lines. So let me draw the lines so that 3 cache lines. Okay. So let me draw a line in between. Okay. So let me write down the same question here so we can solve it later on with the 4 cache lines. 4 cache lines. Okay. Yes. So let us start. So initially, so let me change the color. Okay. So initially there is nothing, right? So let us give 1 here. So 1 here, 2 here. Okay. So most students will be saying that, is there any trick to fill this faster? Like most students will be interested in it, right? Yes. So use your finger, guys. Okay. Yes. I'll be using the pen here because if I use my finger, again you will be you can't see clearly, right? Yes. So let me point this pen with it. Okay. Yes. So once you enter the first element, point that first element, guys. Okay, so point that row. Okay, so 1, 2, 1, 2, 3. Okay, so now 4 entered and all slots are full. So where is your pen now? At 1. So replace that 1 by 4. So once you have replaced it, move it down, guys. Okay, 2, 3. Okay, again 1 is also not having it is not there in the list already. So let us replace this 2 now. So basically where pen is there? 2, 2. So replace that 2 spot. So now move the pen below. Okay, so now the same operation 2. So again it will be replaced by 2. So from here move the pen to the top. Okay, similarly let us continue. So 5. So replace 4 with 5. So 5, 1, 2. So 1 is there, 2 is there. So don't move the pen, guys. So whenever you are striking them off, don't move the pen. So now moving on. Okay, sorry, I think I should move the pen, I forgot it. So once I replaced 5 here, I will move the pen down, right? Yes. So this is already there, this is already there. So now coming to 3. So 3 should be replaced here, right? So 5, 3 and 2. Similarly move this down. Coming to 4. Okay, 4. So 4 is not there. So it will replace here. So 4, 5, 3. So 5 is already there. So no change. Got it? Yes. So in this way, so with the help of a pen method, you can solve, guys. So if you solve like 5 to 10 problems on the same topic, there is no need of this pen also. You can directly solve it, guys. Nowadays, I am able to solve them directly without even using that finger concept. Okay. Yes. So now let us first of all count how many faults are there. Okay. Faults or misses. So these are called as faults also, guys. Okay. So 1, 2. Okay. Let me write it. Miss, and rest are hits. So there are 3 hits and 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are total 9 misses, guys. Okay, yes. So I request everyone to pause the video and try to solve the same problem for 4, guys. Okay, anyway I'll be solving it, so don't worry, but please solve it on your own. Okay, yes. I think everyone has solved it, right? You pause the video and solved it. Okay, yes. So let us continue. So first 1 will come, then 1, 2, then 1, 2, 3, then 1, 2, 3, 4. 1 is already there, 2 is already there. Okay, 5 is not there. So 5, 2, 3, 4. 1 is not there. So 5, 1, 2, sorry, 3, 4. Okay, 2 is not there. That is a 5, 1, 2, 4. 3 is not there. 5, 1, 2, 3. 4 is not there. 4, 1, 2, 3. 5 is not there. 4, 5, 2, 3. So how many misses are there here, guys? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So in total there are 10 misses and 2 hits, guys. So if you observe, here there are total 3 cache lines. Here we are having 4 cache lines. Even though the cache lines have been increased, along with that the miss also has been increased. So this concept is nothing but Bilede's anomaly, guys. So now you got an idea, right? So what exactly Bilede was saying? Okay, so whenever we increase the number of cache lines, the faults should decrease, right? So manually based on logic also they should decrease, but here they are increasing. So that is nothing but Bilede's anomaly. Got it? Yes. So I hope everyone got a clear idea with respect to FIFO, right? We discussed about one page replace or one cache replacement algorithm. Okay. Yes. So in the next lecture, let us discuss the next method, that is LRU, that is least recently used. Okay. Yes. So let us meet in the next lecture and discuss about it. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.